Right, okay, so before I kind of get going, I thought I'd tell you a bit about who I am, so you understand kind of where I'm coming from and my biases, I suppose. So for the last decade, I've been working in university academic research and education. I've been running a genetics lab for conservation and sustainability. I've also spent some time working in scientific publishing. That was my first job out of uni. And quite a bit of time in Parliament translating science for politicians. So this is kind of the biases that go behind everything I say. So a couple of months back, I quit tenure, which all my colleagues think was crazy, but I'm now a director of one of the Foam studios. So Foam was set up about 15 years ago in Brussels as a network of transdisciplinary labs for speculative culture. And that basically means asking, how can we do things differently? There are labs now all over the place, and I run one down here, very southwest tip of the UK. It looks like this, very beautiful, but the reality is that we've got 1 in 5 kids living in poverty now, and it's getting worse thanks to our Tory government. So what we tend to do is try to connect art, science and education and cultivate the beginner's mind. And everything we do is non-profit and everything we do is open access. Okay, so I'm kind of preaching to the converted here, but I think it's kind of worth quickly going through why we even bother doing this stuff. The first one for me is that everyone pays for science through their taxes. You don't pay for a hospital and a road and not expect to use them. Another pretty obvious one, science is better when more people contribute. That could be more people contributing to data, so we have more data, or it could be more people contributing a more diverse range of ideas. And then the next two are the big ones for me. So we have this huge, overwhelming lack of scientific literacy in society. And I don't mean particularly the people who don't get access to decent education. I also mean what we slightly cruelly call in the UK the educated, pale, male, stale group, so old white men. And by this I mean politicians, basically. Okay, so if politicians have poor scientific literacy, we have poor policy. It's as simple as that. The last one is that science matters to people's lives. It affects healthcare, it affects how we eat through fishing and farming, how we adapt to massive environmental change that we're facing at the moment. And any differences in access to knowledge that affects these sort of things equals inequality, which isn't really what we want. Okay, so you all know what citizen science is in here, I'm sure. Like I said, my background is academic, and I quit for a reason, right? A lot of my old colleagues really hate citizen science, okay? And I think probably most people in here love it, and I kind of want to explain the sort of dirty side of it, I guess. So, gruesome pictures. This was my PhD work. This was about, like 15 years ago now. So I used to work on these frogs in the UK who get infected with this virus, and it causes all sorts of horrific symptoms like big skin ulcers and internal bleeding, and they die. Now, the interesting thing about working on these frogs in the UK is that we've kind of destroyed everything, right? So what we haven't built on, we've farmed. So there is no natural habitat left in the UK. So this is pristine habitat for these animals, right? This is somebody's back garden, like a private garden, and it's a pond. And this is where you find any kind of aquatic wildlife now in the UK. So if you want to study this system, what you've got to do is find a lot of people who've got back gardens like this and work with them. So that's citizen science, right? It wasn't called that back then, but it was. And it had massive benefits to us, right? So we set up this field system, and I still have PhD students working on this now. This is one of them. This guy's Lewis, and he's working with a pond owner here. The pond owners tell us when the frogs arrive at the pond. They tell us when they're breeding. They go out, they get samples for us, and when we go out to take swabs, which is a 2-person job, they can help. And that means that we can cover an awful lot more ponds than we could otherwise, and we can do better science. It's a good example of a two-way exchange of knowledge, because the pond owners also benefit because they learn what's killing their frogs and they learn how to stop it. So this is my view of citizen science, right? This is what I was kind of born and raised on almost. And I didn't really understand why all my colleagues hate it so much until I saw this. And this is a bit cruel, right? This is made by one of my colleagues at the last uni that I worked with. And it's all right, we're friends, it's good. And he decided basically that he wanted to map magpies, right? And he had this great idea. He'll make a game where you put it on a smartphone, people download it, they press a button every time they see a magpie, okay? And it maps automatically. Some of you can probably foresee the problems of this, right? I don't know what you think a map of magpies looked like, but probably not quite like this, right? Okay, so this is London. This is Cornwall, where it was made and all his friends are. That's the motorway between London and Cornwall, all the roads going out of London. Okay, so this is not a map of magpies. So for all the money and time and effort that's gone into designing this system, all the money and time and effort that all these people have spent giving data to this, the data that's come out is completely unusable, right? It's useless for science. It's a complete waste of everybody's time. Except now, hopefully, people will learn from it. So that's kind of the worst case scenario. And I want to give you an example of one that we made at Foam, which also fails, but kind of goes quite good in the end. Right, so this is a butterfly wing pattern game, which was done with people at Cambridge. So probably can't see this very well, but butterflies flap around the screen. There are a couple of them here, and they have different patterns on their wings. Some of them are toxic, some of them are healthy, and if you eat a toxic one, by clicking on it, your health goes down. If you eat a good one, your health goes up. It's a very simple game. Now, the guys at Cambridge basically gave us a model of evolution in this system, and also a model of visual predation in this system, which is what we based the game on. Okay, so it's designed on their theory. And yeah, it failed, right? Completely. So this is the end point. You have butterflies at the beginning that look different to the end. But what basically happened, what caused it to fail is an assumption in the science, right? So they assumed that your learning would be gradual. So you would gradually get better at recognizing a butterfly that was toxic, and by the end you'd be great at it. The reality is, actually, if you eat a butterfly and it's got some red on its wing, you never eat a butterfly with red on its wing ever again, right? So it's a step change in your learning. It's not a slow, continuous process. And that caused the game to fail, right? So we managed to fix it. We managed to make the game work. But in doing so, we proved the science to be wrong. Okay? So the fundamental theory was incorrect. And I think this gives a really nice example of where working kind of in this space in between the arts and sciences can give you an answer that you would never get to otherwise. Okay, so I've said my colleagues have gripes with citizen science. I have a little one as well, in that I find it a bit unidirectional, right? So science benefits a lot, citizens don't benefit quite so much. And I'm interested in whether we can move beyond this model and start allowing people who aren't professional scientists to be developing their own ideas. And obviously there are loads of things that can help. We've been talking about loads of them today. And I want to quickly go through three: physical space to actually do the work in, a nudge to actually get started and support to carry on developing ideas, and then finally access to existing knowledge so you're not reinventing the wheel all the time. Okay, so I think we're doing great at community spaces actually. This is the London Biohack Space. It's a molecular lab that was set up for about 1,500. The molecular lab that I set up at the uni, probably 100 times that, something like that. So it's ridiculous. And people use this, right? So the community can go in, they can learn to do cloning and all sorts of things. They're the first UK community, I think maybe even European community lab that's allowed to do GM work. I might be wrong about that. You probably know better. And then this is our foam studio down here in Cornwall. And we've embedded this a bit in our structure because we have a space that anyone can come and develop their ideas in, right? So it's just open for people to come in, they can talk to us and develop what they want. And that's kind of, I just wanted to say that because that's an example of how you can embed these principles in pretty much any organisation. Right, so I wrote this article at the peak of my despair of working in university. And really, I put it up here to highlight one thing, which is I think we're missing something with these sort of biohack labs. Universities, certainly in the UK, have pretty much made it impossible to do any interesting research. You know, the bureaucracy and the metrics that people are under means that it's just not possible to do anything that's really innovative, right? Or risky. And I think these places offer a real opportunity, not just for sort of community members, but also professional scientists to go and pursue their more risky, interesting ideas. Okay, so as we just heard from James, one of the big problems to providing physical space is that the barriers to actually using it are really high, right? I think a lot of you put your hand up when you asked who'd gone in them. I don't know if you felt the same, but I feel that they're quite intimidating, right? They're usually all men. It's usually a community that's already established, and it's kind of a bit uncomfortable, right? And one way that helps with this is workshops, where you're kind of pretending you're doing something else, right? You're not there, you're just doing something that the workshop's about. And I think a lot of hack spaces are doing a really good job at this, you know, a lot of community spaces. And they're running lots of workshops that are getting people in. And that allows communities to develop and provide ongoing support. But I'd have one little urge here is that those workshops could be more collaborative. You could get more and more institutions involved, and then those networks get even bigger, right? So people have a much bigger boost at the beginning. So this is a rubbish picture of one such workshop that we did at Foam. And this is a collaboration between Foam, the London Biohack Space, University of Falmouth, which is arts uni, University of Exeter, which is all sciences, and a place called Jubilee Wharf, which is a kind of community little business boost place. And we got basically an unsuspecting bunch of people in from the local community to do a little project around yeastograms. It's not something we developed, it's by a guy called Gunther Seefried. And it's basically you make agar out of potatoes, you dye it black with charcoal, you spread some bread yeast on it, and you stick the whole shebang under these high-powered UV LEDs. And basically wherever you've drawn a nice picture in black, the light can't get through and the yeast can still grow. So you end up basically with a photograph made out of microbiology.